Hi, good day, my dear students. Today, we're going to open a new chapter on chemical reactions and balancing chemical equations. I presume that you have already learned on how to write correctly the chemical formulas of the inorganic compounds. That was our lesson last meeting. Today, let us have the types of chemical reaction and how to balance these chemical equations. Now, what is a chemical reaction? A chemical reaction represents a chemical change, meaning for all chemical changes, a chemical reaction can represent it. And there are types of chemical reaction. One, we have the direct combination, or known as synthesis. In the direct combination type of reaction, there are two or more reactants forming only one product. And the pattern for this direct combination reaction is A plus B equals AB. So there is a direct combination of the reactants. For example, hydrogen plus oxygen equals water, or H2 plus O2 equals H2O. Another one is magnesium plus oxygen equals magnesium oxide, or Mg plus O2 equals MgO. Now try to recall that all gases, when they undergo a chemical reaction, will use its diatomic form. That's why the oxygen and the hydrogen takes the H2 form. Another type of chemical reaction is the decomposition reaction. Now, in the decomposition reaction, there is only one reactant forming two or more products. So the pattern is AB equals A plus B, or ABC equals AB plus C. There are ways on how to decompose a substance. One is by heating, another is by burning, another is by decaying, then there is digestion, and electrolysis. Now, what is this electrolysis? Electrolysis is a method of decomposing a substance using an electric current. Or that means a substance, if you want to decompose it by electrolysis, you let an electric current pass through the substance. For example, the water. Now, water cannot be decomposed by heating nor boiling, but this can be decomposed by electrolysis. So, if you have water, or the H2O, then decompose it by passing it through an electric current, then the products formed are H2 and O2. Another is the decomposition of the potassium chlorate, or the ClO3. Now, you can decompose the potassium chlorate by heating it. So, the products formed are KCl plus O2. So, that means there is the salt form plus the release of the oxygen gas. The 1A metal bicarbonate. The 1A metals are those belonging to the 1A family, or the alkaline metals. Suppose you have sodium bicarbonate. Take note, sodium is a 1A metal. The bicarbonate of sodium is sodium bicarbonate. When you are going to decompose a 1A metal bicarbonate, the products formed are the metal carbonate plus the carbon dioxide plus the water liberated as gas. For example, we have the sodium bicarbonate. Now, when this is heated, this will form the products sodium carbonate plus carbon dioxide plus water, or NaHCO3 heated will form Na2CO3 plus CO2 plus H2O. The gases liberated are the carbon dioxide and the water. When you are going to decompose a 2A metal bicarbonate, meaning these metals belong to the 2A family, then the products formed are the metal oxide plus the carbon dioxide and the water liberated as a gas. For example, we have magnesium bicarbonate. When you are going to decompose this, the products formed are magnesium oxide plus carbon dioxide plus water liberated as a gas. So those are examples of decomposition reaction. Another type of chemical reaction is the replacement or displacement reaction. In the displacement or replacement reaction, this is dependent on the stronger elements which will replace the weaker elements as based on the electromotive series or the halogens as arranged in the periodic table. Now, what is this electromotive series? The electromotive series is a list of metals wherein they are arranged according to the descending order of reactivity. Something higher in the list can displace something lower in the list. For example, the lithium is placed as the highest in the list. So lithium can displace all other metals in the electromotive series because the higher it is listed, the stronger the metal. And the lower it is listed, the weaker is the metal. On the other hand, the halogens, as arranged in the periodic table, we have fluorine, chlorine, bromine, iodine, and astatine in that descending order. That means among the halogens, the fluorine is the most active one. So this fluorine can replace the chlorine if it is in a chemical reaction and all the rest which is below it. For example, if we have a chemical reaction between the iron nail and the cupric sulfate, take note, if you have the list of the electromotive series there, the iron is higher than the copper of the cupric sulfate. So there is the tendency of displacing the copper of cupric sulfate by iron. So what will be the product if the reaction is iron plus cupric sulfate? So we have the products ferrous sulfate and copper deposited as a precipitate. Another example is, suppose we have sodium chloride. Then we will react this with fluorine. Take note that the fluorine is higher than the chlorine in the list as you are going to look at the periodic table. So that the chlorine in the sodium chloride can be replaced by fluorine. So the products formed if sodium chloride reacts with fluorine are sodium fluoride plus chlorine. Another type of chemical reaction is the double decomposition, or known as the metathesis. In this type of reaction, there is an exchange of atoms between reacting compounds, or there is an exchange of elements between reacting compounds. And the pattern is AB plus CD equals AD plus CB, taking into account that A and C are cations, B and D are anions. Now, for example, we have a reaction between barium chloride and potassium sulfate. Now, barium will take the element sulfate from potassium sulfate, and potassium will take the chlorine of barium chloride. So the products formed are barium sulfate and potassium chloride. Another type of chemical reaction is the neutralization reaction. This is a double decomposition reaction specific for the acids and the bases. The pattern for this reaction is acid plus base equals salt plus water. For example, we have sulfuric acid reacted with sodium hydroxide. So the products formed are the sodium sulfate as the salt plus the water as its byproduct. Another example is hydrochloric acid plus potassium hydroxide. So the products formed are potassium chloride plus water as its byproduct. So those are the types of chemical reaction. Now let's go to balancing these chemical reactions. Now, a chemical equation can represent a chemical reaction. There are the reactants and the products. The reactants are written at the left, while the products are written at the right. These two are separated from each other by an arrow or an equal sign. And we can balance this chemical equation by inspection, meaning you can check or inspect the number of atoms in the reactants to balance the number of atoms in the products. Now, there are suggestions on how to balance a chemical equation. Number one is start balancing from the most complex part. So you have to look in the reactants or in the products which of them is the most complex one. Then that will serve as your reference point. Number two suggestion is balance the polyatomic ions by group. In here, you are going to consider the number of polyatomic ions in the reactant to balance it with the number of polyatomic ions in the product. Another suggestion is balance the monoatomic ions last. And if fractions appear while you balance the chemical equation, convert these fractions into a whole by multiplying it with the least integer or the smallest integer to make it a whole. So those are the suggestions on how to balance a chemical reaction by inspection. For example, the reaction between magnesium and oxygen. If magnesium reacts with oxygen, the product form is magnesium oxide. So you can see that magnesium plus oxygen, which is O2, will form MgO, or the magnesium oxide. So look at which of the three is the most complex part. If you're going to check or inspect, it is the MgO which is the most complex part. So this will be your reference point. You check how many atoms are there forming this product. So if you're going to check it, there is one atom of magnesium and one atom of oxygen. But look at your reactants. You check whether there is one atom of the magnesium. So when you look at it, there is also one atom of magnesium in the reactant. But when you look at the number of atoms of oxygen, in the product you have only one atom of oxygen, while in the reactant there are two atoms of oxygen. So you have to multiply the product by 2 in order to balance the number of oxygen in the reactants. So this time you have 2 atoms of oxygen in the reactant forming 2 atoms of oxygen in the product. But what happens to the magnesium? The magnesium in the product becomes 2. So automatically you have to place the number 2 before the reactant magnesium in order to balance the number of atoms of magnesium in the product. Another example is that of the reaction between lithium bromide plus fluorine. Take note that the fluorine is a halogen, and when a halogen reacts, it will take the diatomic form. So the reaction will look like this: LiBr for lithium bromide plus F2 for fluorine will form the products LiF plus Br2. So how do you balance this reaction? Look for the most complex part. So seemingly, the most complex part here is the LiBr, or it may be LiF. Now, let us consider the LiBr as the most complex part. Look at the LiBr, or the lithium bromide. There is only one Li, or there is only one lithium in the reactant, and there is also one lithium in the product. Go to bromine. In the reactant, there is only one bromine, or Br. But in the product, there is 2 atoms of bromine, or there are 2 atoms of bromine. Now, the bromine here is not balanced because there are 2 atoms of bromine in the product, but only 1 atom of bromine in the reactant. So you have to place a number 2 before the LiBr, or before the lithium bromide in the reactant. So placing number 2 before the LiBr balances the number of atoms of bromine. But what will happen to the number of lithium atoms in the product? So you have also to multiply or place a number 2 before the LiF in the product. So you have there 2 LiF. Inspecting the number of atoms in the product in terms of the lithium, you will have now 2 atoms of the lithium in the product and 2 atoms of the fluorine in the product. And when you're going to inspect the number of fluorine in the reactants, there are 2 atoms of fluorine. Those are some examples on how to balance a chemical reaction. I will be sending you also a video on the types of chemical reaction as we have performed, or as I have performed and demonstrated in the laboratory. Kindly also view that video. I will also be sending you notes for these types of chemical reaction and how to balance chemical reaction, and an exercise for you to work on. That would be all for today. This is your teacher, Professor Nisitas Ruiz of Holy Name University.